Here we have a phonograph record rotates at 33.33 revolution per minute. Find its angular velocity in radians per second and the speed of a 0.5 cm from the center. First we convert the angular velocity from rev per minute to radians per seconds, which we obtain as 3.49 radians per seconds. For the speed at 0.5 cm we use the formula for the tangential velocity, since it is the velocity that describes the nature of the problem. The equation for the tangential velocity is equal to its radius times its angular velocity, which we obtain the value of 0.1745 meter per seconds. Here we have the same problem, but it starts from rest and accelerates with constant angular acceleration to 33.33 rpm in 2 seconds. We are asked to find the angular acceleration and the angle turned through, in degrees and in revolutions. We also add to this problem some assumptions that it also starts at time 0 at a position of θ naught 0. To find the angular acceleration alpha, we use the formulation of average angular acceleration, which is the change in angular velocity over the change in time, and gives as a value of 1.74 radians per second square. To determine the position as it turns at this point in time, we use the equation of motions for rotational at a constant alpha. Here we see that with the given and plus the value of acceleration we can use equations 2, 3, or 4. For this case we use the equation 2. We then substitute the values that are present and obtained a theta at time 2 seconds, but we need to convert this to degrees and revolutions. For degrees we simply convert this by multiplying it by 360 degrees over 2 pi radians and get a value that is around 200 degrees. And for revolutions we multiply the value obtained by multiplying it by 1 revolution over 2 pi radians and get a value of 0.55 revolution.